Hey there, OBMers. Tim Ludwig here. Got a little behavioral systems analysis for you. And to do that, I got a little story to tell called A Line for the Front Line. So, once upon a time in a refinery, the maintenance was called out to do some work in a unit. This refinery had 6 different units where they made different types of petroleum. And the maintenance was called out to do some updating of some equipment. And to do this, the maintenance planners contacted the warehouse who had to dispatch tools and equipment on a forklift to go out to the unit in the morning so they can put the tools and equipment for the maintenance folks in the afternoon. So you see there's a forklift and a flag person. That flag person is there to look around for hazards and alert other people in vehicles and walking to the forklift, and they were going out there to the unit. So after stopping, they have to get a permit. Whenever you go onto a unit, they have to go by the blast shelter where the operators are to get a permit to make sure that you are ready to go onto the unit. So the driver and flag person got the permit. They were going out to drop off their equipment at the drop-off point, and a member of the behavioral safety team noticed that the forklift was going down a passageway between 2 pieces of equipment and was nearly about to hit some overhead piping. So this would have been a disaster. It would have been quite serious injuries, if not a fatality, to the forklift driver and flag person, but also it would have released all kinds of chemicals, caustic chemicals, acidic chemicals, airborne chemicals that would have affected the community nearby. So I was asked as an OBMer to try to diagnose why this happened and give the company some idea on how to prevent this in the future in a sustainable way. So the work was stopped immediately. But if you ask why did this happen, or actually almost happen, it's quite easy for the managers, the leaders, even OBMers to blame the worker. I mean, this person should have known the mast of their forklift was too high to go down some areas of the plant. And what's that flag person doing anyway? That's their whole job. So of course, that's what they did. They had disciplined this 2 folks from the warehouse. They lost pay, they lost days of work, and they got blamed. They got blamed. But did the refinery really solve the problem? So let's look into this a little bit more. You know, quite typically when we have performance flaws, either safety, quality errors, production flaws, things like that, we tend to blame the worker because their behavior is usually the last thing to happen before the error, before the injury, before the close call, before the quality problem, before the upset client. And when behavior doesn't produce value and performance is all over the place, we tend to blame the worker. Blaming the worker, however, is not the root cause of the variance that causes errors. I mean, if you look at any set of data, then you looked at industrial errors, you look at any kind of organizational errors, it's quite easy to conclude, especially in safety, that 80% of errors are associated with human behavior. But we know as behavior analysts that that's not the right question to ask. Instead of asking what the causes of the error may be, we instead ask what is the cause of the behavior. And when we ask that question, our science, psychology, Skinner, Deming all say that 80% of the reasons why we do what we do, maybe 90% between you and me, are due to the system we are put in. A bad process is going to beat a good worker anytime. Only 20% is due to the person, their motivation, their intelligence, their personality. Changing the person, if you decide that's the root cause and you need to change the person through coaching or retraining, that's going to be difficult. And if you're able to do it, which you're probably not, your efforts are going to only affect one person. And you're leaving 80% of potential improvements just right there on the table. So to get performance, to think about how we can build a system that is going to drive the success of the workforce, we got to create a process and an environment that sets up the worker to succeed, that gets the behaviors that are desirable. So performance must be supported by virtually flawless systems, considering skills, knowledge, reminders, priorities, expectations, feedback, scheduling, time allocation, procedures, processes, tools, instruction, help from others, et cetera, et cetera, et cetera, to get performance to produce the value that a company is paying for with their labor hour. Deming said, your system is perfectly designed to get the results that you see. And in OBM and behavioral systems, we might as well say your process is perfectly designed to get to the behaviors that you shaped. So the problem is that managers don't have any visibility to this behavioral variance that eventually may be related to a serious issue like the one that we have in our story. The only thing they know is things are going okay until they're not. And then that's the crisis, it hits. And then they tend to have crises happening around and about over and over again. And how much of this is indeed due to behavioral variance? Well, most of it, most of it. The problem is when we have these crises, these special causes, we tend to go and over-engineer the solutions. In safety, that means extra layers of protective equipment, extra rules and procedures, extra layers of oversight, and it does not help the worker work any safer. And frankly, they're the kind of things that workers tend to exhibit counter control around and end up pencil whipping or simply not doing it all. So instead of that, let's understand what Deming taught us. Deming is considering variance, and if you don't know W. Edwards Deming, that is an area of research you need to get into. W. Edwards Deming, in his career, was a statistician. I got to see him a number of times, and in his statistical approach, he taught us that behaviors vary, performance based on behaviors vary, outputs of teams vary, outputs of functions and organizations vary on a day-to-day, hour-to-hour basis. And that variance is what we need to look at. And if the variance is out of acceptable limits, if it's broad, the standard deviation quite large, then he calls this out of control variance. The process is what he speaks of, not the person. The process is producing this out of control variance. And so therefore, special causes like crises are influenced by out of control variance quite predictively. As we investigate an unplanned event, we look for this out of control variance because getting variance under control is our job as OBMers. Think about that for a second. Getting variance under control by examining how the process influences behavior, that's our job as OBMers. So where do we find this variance is out of control? Well, we analyze behaviors associated with an unplanned event in the context of your processes, and there you will find the variance. And there you'll find a sustainable solution. Right there in the background is the whiteboard of the ABC process and behavioral systems analysis that I did for this company to come up with 3 levels of solutions. So behavioral systems. So we're seeking to understand the reasons that influence behavior from both our frontline workforce, our managers, our leaders. And when we do our behavioral systems, we understand that some of the causes of behavior are proximal. They're near the worker, the environment of the worker. That's like their supervision, their tools, their equipment, the task steps. But we fail to look at quite often the distal reasons, the systemic reasons why we end up designing an environment that creates the behaviors that we may be concerned with. So those distal factors are further away in time and space from the worker. And they include stuff like workflow processes, the engineers who design the workflow processes, the procurement engagements, like contracts and the like, other engineering considerations that design the equipment, and ultimately, among a whole host of other systemic issues, leadership behaviors. So when we do our behavioral systems, we need to look at both the proximal and the distal reasons why we put the worker in a position to make the error. So we, of course, start at the beginning with our ABC analysis, understanding what situations we're putting the worker in so they behave a way to have the consequences line up that motivates their behavior. So let's go back to the story. If we're trying to understand what happens over there on the right, where those two workers nearly caused a disaster, we have to go backward in the process. Yeah, that's right. Go backward in the process because usually there are controls and other factors that are trying to manage or fail to manage the worker's behavior. So in our story, we had the work order from the warehouse. They had to stop by to get permits from the blast shelter where the operators who run the plant are at, and then they make their delivery. So, you start asking, well, what are the antecedents in the worker's environment for this forklift driver and flag person? And we find out when we start asking, what's this permit all about? We find out that the operator is supposed to do a couple things. In the permit, they're supposed to verify the load, make sure it's the right equipment and tools for the maintenance people, and location where they're supposed to go. They're supposed to inspect the vehicle to make sure it doesn't break down or cause a hazard when they're out in the unit. They are supposed to walk the correct route and point out the hazards. And then they get to issue the permit. And so if you do kind of the quick ABC analysis, as this is an antecedent for our forklift driver and flag person, we could see that if they got the correct route walked and the operator pointed out the hazards, the operator would have said, hey, don't go under this overhead piping. Go around the outside in the road designated for this purpose, and then go into the unit at this point. So you can see if that would have been the antecedent, we would have been able to manage the driver's behavior. In fact, that's the whole purpose of the permit. So do we blame the operator? The people at the plant called this a couch permit. Do we blame the operator though? It's quite easy to say, you should have done this, or were you lazy? You just didn't go out and walk the unit. Well, let's go. Now we're back in the process by a couple steps where the forklift driver goes to the operator, and the operator is supposed to do a set of permitted behaviors. Verify the load, inspect the vehicle, walk the correct route and point out the hazards, something they call a joint job site visit, and issue the permit. So let's do an ABC analysis on this. Well, what are the consequences? When you do an ABC analysis, it's good to start with the consequences because the antecedents that are related to the consequences are the strongest. So let's look at the consequences of doing a successful permit, these 4 steps. Well, they told me it took about 20 minutes to complete. And that's kind of reasonable, but a bit long. They're exposed to weather. Now they have to go out in the heat or the rain or the snow and have to spend time with people from the warehouse. And but in the end, it helps assure a safe and effective delivery. But now let's look at the antecedents. So you can kind of see how maybe somebody wants to be a couch permitter, but in the end, this is their job. Now let's look at the antecedents. It's a very long form. It's like 108 items, so it takes a long time to get through. They have other work to do. They got their full-time job. But then they told me, Tim, sometimes they get 17 permits a day. 17 permits a day. Can you do the math? 17 times 20. I can't really come up with that quickly, but they have a day job and they can't spend 6, 7 hours doing these permits when they have other stuff they have to do. I mean, just look at this ABC analysis and you can see where we have the problem, So these operators, therefore, are having to do couch permits because they can otherwise not get all the permits done. So we don't blame them either. So what we hear here is that variance at the point of the front line can be influenced by variance somewhere upstream in the process. So out of control variance is the problem here. Our job as OBMers, using our process improvement behavioral techniques, is to reduce the variation. The trick is to reduce the variation at the point where we can have an impact. So do we blame the operator now? I mean, this is where the out of control variance is. Well, no, we can understand from our ABC analysis that they have too many permits. So they have supervisors that are supposed to make sure the operators do the permits. Do we blame the boss? No, look, the boss is on a computer answering questions from their bosses. who are asking them to go to meetings and keeping the supervisors from even understanding how much variance there is in the front line. So supervision typically is not the answer. So how do we get this variance under control? Well, let's continue our behavioral systems analysis going backwards in the process, but now we go across functions. We already had the warehouse workers interacting with the operators, but we can ask the question, if we indeed have an antecedent for the operators, sending them 12 to 17 permits, usually in a morning, you got to ask the question, or upstream in the process, who's sending all these permits to them? And then we go into the maintenance. And in maintenance, they have an activity called maintenance planning. This is part of their function. There are engineers doing this in air-conditioned offices for their job, planning the work that's going to be going out into the unit, planning the equipment and tools and permits and things like that. So they're the ones sending the permits. So now let's go into their process and understand how it may be causing variance. So there's our maintenance planner. So the maintenance planner, they have certain inputs and all the input-output relationships we talk about in behavioral systems analysis. And they use reliability metrics, how well the unit's running. They have people in maintenance doing inspections, and they have preventive maintenance. And all this data comes in, and they're able to design a plan going out to the unit, and they told me that would only be about 3 permits a day. 3 permits a day, that's quite under control. And I asked him, I said, well, what is your life like? You got these inputs, and then you put the maintenance plan together and you send it out. Is there any other variation? He goes, oh yeah, sometimes my boss comes in and says, hey, we need to prioritize this over other things. And then we get the people from operations called asset coordinators, the people who own kind of the equipment, saying, I need this fixed right now. And then we got people from the chemical engineering, the area team engineers coming in. I'm not getting the correct readings. I need this fixed now. And then we got the projects out there saying, well, you can't do this. We're going to have our equipment there. You got to do this. And then you even had the frontline leaders saying, I broke it and we need it fixed right now. And what we had initially was an under control process now is out of control. As we look at the relationship map here, and we start looking at the different functions of the refinery, a lot of people in the front office and air-conditioned offices all asking maintenance planning to put their task as a priority. Now, the maintenance planner is a willing worker, wants to make his or her boss look good, wants to make the refinery work better. And so they're just sending out all these permits to the operators who then can't get them all done. And then you end up with a crisis on the front line. So variance, out of control variance, done by people in a different part of the plant at a different time, who are virtually unaware how their behaviors are impacting the behaviors of folks downstream in the process. So out of control variance upstream can lead to out of control variance downstream. And if we fixed the front line where the issue nearly happened way over on the right, we're only solving one situation. If we fix the permits, well, we're basically forcing the operator to pencil whip. But if we fix maintenance planning, we're going to fix so many sources of variance downstream that it's worth the time of spending time upstream in the system distally to fix the problem instead of downstream where we're only helping 1 or 2 people at a time. So when we allow variance to be out of control upstream, we're really forcing the problem on the front line. We're pushing the variance on the front line. Frankly, they're heroes because they can take all this variance and pull it off, be productive, have quality work. The only problem is they take shortcuts that can hurt their safety, their quality, their health, their well-being, their production. And so they get really good at bypassing these out of control processes that come at them. They pencil whip and other things. When we look at behavioral systems, we learn, as we look at the process map here with swim lanes, and each swim lane being a different function in the company. So operations is where they do the permitting, procurement at the bottom is where they do the deliveries. You have tech services, you have maintenance as different functions. And because you are accountable to your boss who holds the interlocking behavioral contingencies between you, your team, and your boss, we get pretty good at within our functions at keeping variance under control. We optimize our function typically at the expense of our steps that go across functions. So I will bet my bottom dollar as an old-time OBMer that out of control variance that cause crises and other upsets or problems in quality and service delivery are typically associated with process steps that go across functions. Those are the ones that typically don't get attention. This is where we're going to make our biggest impact. So we should spend our time working across functionally with our teams to come up with solutions that that get rid of the barriers to our front line. And so we need to align our processes across functions and put our front line in position to succeed. If we get variance under control in our upstream processes, we get variance under control at the front line. This is what I call a line for the front line. It's been what I've been preaching when I when I do keynotes with leaders all over the world in safety and process safety and performance improvement. When we talk to them and try to teach them behavioral systems, it's for aligning the front line. And so once we start looking at the cross-functional variance and we get that under control, then downstream we'll have less errors because the worker's in a position to succeed. And when they succeed, the business results in the end will come. So in order to align for the front line, quality improvement gurus like Deming and others, like the folks who are in Lean Six Sigma, like the folks who do the Gemba walk, will tell you in order to make the task, the environment that the task is in, the processes, in order to make those to allow the worker to succeed, in order to make those successful, in order to remove the barriers to the worker's success, we need to engage the front line to make improvements upstream. We need to engage, listen, and learn to align for the front line. And there it is. There's the draw up I did of the behavioral systems analysis with all the content there. And I hope you enjoyed this little story that put us in the position of the workers. I thank you for being an OBMer, and I hope that this series of OBM talks will teach you something and you in the future can contribute. Take care.